Hey everybody, welcome back. I know I keep promising we're going to get to assembly language, and I promise we're going to get there, but it's really important to set up some of this foundation, going through the documentation and really understanding what we're doing, and then trust me, we're going to get to some assembly language code next. But first I wanted to get to understanding the GPIO. So GPIO stands for General Purpose Input Output. And it is where our all of the pins on the board are, the high five pins, and it's also where our LEDs get addressed, so our red, green, and blue LEDs. And so if we go back to looking at our documentation where we were at, you'll recall that we started by looking at the overall memory map. So let me just reset us back to the overall memory map. And we cared a lot about this one right here, which is our GPIO. There we go. And this is our base address. And then from there, we go down to our GPIO chapter, our GPIO section, and we find that we have all of the registers here. And so as I mentioned, we're going to use our output enable. So this is the equivalent of a pin mode output setup. And then we're going to write all of our values to the output port. So this one here, that's how we're going to turn the LED on and off, is when we actually write a value to this port. That's where it's going to go through. And then, as I said, we're going to invert the default values by using XOR. So the thing that's sometimes confusing to understand is we have all of these register addresses, all of these addresses that we can read and write to. But what do they mean? And so what happens is that these are all 32-bit addresses, and every one of them represents a bit on or a pin on the board. So bit 0 is pin 0, bit 1 is pin 1, and so on and so forth. And so that's how we're able to talk to the different pins, by writing to the right place. So if you recall, when we looked at the Freedom E10.3 pinout, we have the green, red, and blue, and here's our GPIO offset of 19, 21, and 22, and so that represents this bit field in this 32-bit register. So because that's a little bit confusing to talk through, I drew a picture to try and help you understand what's going on. So from every one of these, from the GPIO control register, which starts at this base address, and then for the next hexadecimal 40 values, it's basically a bit field that represents the pins on the board. And that 19, 21, and 22 is basically telling us which bit represents the green, the blue, and the red. So that's why what I did is I drew 32 bits, right, from 0 to 31. So it starts at 0, goes to 31. There's 32 bits. And then I highlighted the green LED, green offset 19. The blue LED is 21. The red LED being 22. And then what happens is we can take all of this and convert it into hexadecimal values. So let's start at the bottom. I put a 0x to represent hexadecimal values. And for the green LED, I have all zeros, but I have an 8 here because the upper bit is set here. So that translates into a hexadecimal value of 8. When I go up to the blue, I have only this bit here that's set, so I only want the number 2, so that's the hexadecimal value there. And then red is, of course, the one right next to it, so that's 4. Now, if I want to essentially set all of the bits all at the same time, then if I set this to 6 and this to 8, then what happens is I've addressed the red, the blue, and the green all in one fell swoop by essentially referencing RGB. So if you recall, when we were writing our header file, I said, hey, I've got these hexadecimal values that I'm going to use to represent the red, the green, and the blue LEDs. Well, this is where they come from. So they basically represents this bit field offset that's clearly outlined in the documentation. But connecting the dots from, a GPIO offset, a pin number into a register kind of gets confusing to put all of those dots together. So that's why I kind of drew this picture to hopefully get you through and understand how the GPIO works. And so with this information, now it's very easy for us to write assembly language code that can talk to the GPIO register, and we know exactly which pins or bit field we want to talk to. So each of the bits in the bit field represents a pin on the board.